and net force?
Yes, good question. And we need to calculate the proper acceleration, even we are talking about the uniform circular motion. Did the teacher mention that we are only confined to discuss uniform circular motion?
Yeah, only
the velocity is constant.
Yeah.
So basically, the acceleration is related to the change of direction, constant change direction, the velocity change direction. So that is very special acceleration we are dealing with. Obviously, you know some formula now. What is the name for that particular acceleration? Which is toward the center, right? Centripetal, yeah, which means centrifugal is outwards, centripetal is inward to the center. So obviously you have experience, you make some rotation. Okay, if you use a rod holding the object, obviously you have need the string to keep that direction changed. Otherwise, the object will just fly away. So you can feel the force. You can, according to Newton's law, the force is proportional to the acceleration. So therefore, actually, you can feel that force, which the force is actually, you feel the force is actually outward, but the force acting on the object is inward. Does that make sense?
Yes.
Because according to Newton's third law, that action and reaction. So if you have action, so if you act something, so the force is, you provided the force toward you, but that force is acting on the object, right? According to Newton's third law, so the object has pull you, right?
Yeah.
That's correct. Right? If I use can we use can we draw the circular motion? Can we draw the circle? So can you work out the direction of the acceleration in this diagram? If this is the orbit or is the trajectory of the object, can you work out the direction of the velocity and the direction of the centripetal acceleration of that object?
Is the acceleration always towards the center?
Towards the center, yes. So that is, can we use this arrow to indicate? So that toward the center, right?
Yeah.
So that is direction of the acceleration. How about the direction of the velocity at this moment?
Straight.
In what way?
Forward.
Can you use the arrow to indicate the direction? You can choose. You can choose the tool from this matrix. That's the second. Yeah, that's right.
Oh, sorry.
Yeah, you can jump to the. You use a stamp, right? You can use a draw in the draw boxes. Yeah, that's right. That's good. Yeah, that is the direction of velocity. You are right. So that is a tangential direction. Tangential direction, right? So it is always, so these two directions are always perpendicular to each other. So that is relation between the velocity and acceleration. So this acceleration. Did your teacher put a C here? C for centripetal?
Yeah.
Sometimes, yeah. We just use this notation for vectors. So some teacher use different notation for the vectors, right? We can either use this, we use this different font, a bold font for vector, or sometimes we just use arrow. Some mathematics also use this notation, right? But they represent the vector after all. Okay, if the radius is r, if the radius of the circle is r, can you work out the relation? Can you find the form? Can you write the formula for this acceleration? So given the velocity v and r. So what is the acceleration? What is the c? AC.
Is it
So you can use common sense. The faster, the higher the electricity, yeah. Proportional to velocity square, yes. That's right. This. So this is a basic formula to dealing with the circular motion. Once we know this acceleration, then we should be able to build the Newton according to Newton's second law. What can we say?
F equals ma.
Yeah. How do we find the equation of, can we find an equation of motion? So equation of motion for the circular motion. So Newton's law says the force, right? Force is proportional to the product of mass and acceleration. So in this case, you have to consider the centripetal force, because that is correspond to the acceleration created.
Yeah.
All right. So this is a basic equation. So you can write this equation. You can use this equation, which actually is Newton's second law. This is Newton's second law. So by using this equation, you should be able to work out the acceleration for the given force, because we haven't talked about this the force yet. So the acceleration AC is generated by the force, right? You can rewrite this as F divided M, but FC can be different force. So one of the force just tension. If that's the rod holding the object, the force is just the tension, right? So one force is a tension. Another type of the centripetal force. So this C means the centripetal, right? Centripetal. So another force which can generate the centripetal acceleration is gravity. Okay. So if we just so it could be can we just write formula here? Do you know this formula? That is M. Have you studied this Newton's gravitational law before? Not yet. Doesn't matter. So this is just gravitational. That is the force between the sun and Earth, between the sun and any object. This is called the gravitational force. Gravitational. So that is why you can describe the motion of Earth about the sun by using this force.
Yeah.
And alternatively, this very much dependent on what the force provides this centripetal force. Okay. And can we just go to the alternatively, we can consider this scenario. Have you teachers take this example? For example, if this is a table, and you draw the hole in the middle, there's a hole in the middle, and then you use a rod to connect this wire, to connect this object. You see, so the object says the mass m, and then this is connected with the weight. You put the weight here. So this is another object. There's another object here. So the mass is capital M.
Mm-hmm.
Okay. Now, if we just let these objects doing the circular motion, we just take this example to explain how the equation can be used. So in this case, can we just consider they are doing this is 3D diagram. So they are doing the circular motion on the table.
Mm-hmm.
Okay. Now, if the velocity, if we can measure the velocity, this velocity can use this vector So this is a vector, this is velocity. If we can measure this velocity, so for example, this is just first example. So if we just consider this setup, so if m equal to say 0.5 kilogram, and the capital M is equal to 2 kilogram. So if the velocity is say just 0.8 meters per second. So the question is, so what is R in this case? R is the radius. So R is the radius. So this is a trajectory of this circular motion.
Yeah. So
do you want to try? If you can solve this problem, then I know you understand, you know, this topic, this particular topic.
would if you put it into that formula before.
Yeah, we know the formula. Yeah, you can copy this formula. So this would be the formula we can use. Can see this is the formula. So this is the formula we can apply. This particular formula. Just this is the formula we can apply. Can we copy the formula here? So the formula is that the centripetal force is equal to the product of mass, this is the mass of object, multiply the centripetal acceleration. So this is basic formula we can apply.
How would you calculate the acceleration from the velocity?
Yes, so another formula is we just write down. So the acceleration can be determined. So this is one of equation you can apply. So v squared divided by r. So you can use these two equations. So how would you solve this type of problem? Do you want to just use number at the beginning, or do you want to find out the formula first?
I would put the velocity into this formula, the AC equals V squared over R.
Yes.
And then would you substitute one into the other?
So you want, can we call this formula 1, formula 2? So you want to use formula 2 first, right?
Could you just combine them both?
Of course, yes. This type of question require more than one equation. So therefore, if you just use the numbers, that wouldn't work. You have to basically, to solve this type of problem, you have to build several equations. And these equations are dependent to each other or coupled equation. This is called a simultaneous equation. Then you have to count how many is unknown in these equations. If the number of the equation, if number of equation is equal to the number of unknown, then mathematically you can solve this problem. So you can build this equation based on physics. I give you a clue. I give you a hint. In this case, we have first to work out the relation. So what is this is a good example of the first case where tension will provide the centripetal force. Because obviously this object is connected by this wire.
Yeah.
So when you're trying to solve the physics problem, the first step is to draw the free body diagram. Did the teacher mention that? So first step 1 is to draw the free body diagram. Free body diagram. That will help you to understand the force acting on this object. For this small object, can we start from this object M? So the free body diagram for this M is just use a dot to represent the mass. And then you consider how many forces acting on this object. How many forces acting on this object?
1 or 2, if you
2,
count gravity.
One is gravity, yes. Another is upward. Otherwise, it's not stable, right? So they must have another force upward. So that is force. I think we have to specify at this stage, at this acceleration is 0. So for this object, they're not moving. So it's balanced. So for this object, these two forces are balanced. This chemical is T for tension and mg for gravity, downward. Right?
Yeah.
Now for the second object, which is doing a circular motion, can we use the M? Can we use this? The free body diagram is just reduce everything, every object to the mathematical point, just point. And then we can consider how many forces acting on that. How many forces acting on this object?
Well, there's tension from this
Yeah,
the rod.
You get tension toward the center, right? That's the force toward the center, right? Any other force?
Gravity.
Gravity, yes. I have to first do this one. It's tension, yes. Gravity is downward, right? Gravity is downward. So gravity is downward. Any other force?
Normal force.
Normal direction, which is a reaction from the table. It should be upward, right? The normal force will upward. So that is how to dealing with a mechanics problem. So this is sorry, this should be capital M. This is capital MG. This is MG. This is small mg. This is normal directional force. This is tension. There's good reason because because we mentioned that wire is rigid. So the rope is rigid. We use a rigid wire. So it means that is you cannot extend it. So therefore, because of that, these two forces must be equal in amplitude. Because there's no, you cannot extend or elongate or compress.
Why are they? What?
Because it's rigid. You see, if you put a spring here, and the force were not equal. However, when we say it's rigid, which means this wire is ideal. If you push the force on one end, another end will experience force.
So the whole thing is rigid.
Yeah, the whole wire is rigid. Yeah, rigid is just the ideal case. Okay, of course, there's no such thing as ideal wire. You still can make some extension, elongate a little bit. So in this case, based on this hypothesis, we can assume these two tensions are equal. And because this object is moving on the table, therefore, we can argue that the horizontal, the vertical, in the vertical direction, this acceleration is 0. Okay. So can we just build the equation? So from M1, we can build two equations. One is that the normal directional force take mg must equal to 0. So vertical, there's no vertical movement, see, because there's no vertical acceleration. No vertical motion. So it's our this is our first equation. And the second equation, we can build that in this case, the tension, we're acting as a centripetal force, right? So therefore, we can apply the first equation to rewrite this as mg multiplied acceleration, which is v squared divided by r, with our equation 2. Can you see?
Yep.
This is step 2. In step, we just built the equation. So step 2 is to build equation. We need to build equations. Okay. So that's all. That's all. Can you see? So here we have used these two equations. So we have used this formula that is Fc equal to MAC and AC equal to V squared divided by R. So we have used this formula. So in this case, the centripetal force is provided by this tension. So that is how we build the second equation.
Yep.
For the another object, the equation is simple, just one. So we can argue that the tension, this is net force acting on the second object. It must be also equal to 0 because this is our equation 3, because there's no vertical motion. Same reason, no vertical motion. So in this way, we can build a 3 equation. Can you see that?
Yes.
But if you return to the question, we don't have to use all of these equations. For example, we don't need to know the normal force. So therefore, we don't have to use first equation. Can you see that?
Yeah.
However, if we want to solve this problem, which is R, we have to use both equation 2 and equation 3. So that comes to our step 3, is to solve this question. Solve the equation. Solve for the unknown. Okay. Solve for R. You can use some mathematics skill now. Can you see everything? So we have, once we have built enough number of equations, then we just use some algebra to solve this problem. Do you want to try?
Yeah. Do I do a new screen?
Which equation are you going to use?
The T minus mg equals 0.
Yeah, that's equation 3. Yes.
Mm-hmm.
In which we can solve the T, right?
Mm-hmm.
Okay. Can you combine these two equations? Equation 2 and equation 3. Because in which we need to find the formula for the R. Can you see? This is unknown.
Would T just be equal to mg?
From equation 3, yes, you can argue. You can see that from, can we write what you're trying to do? So from equation 3, we have T equal to mg, right? So that's another equation. Can we call the equation 4?
Mm-hmm.
So what can you do next in order to find the radius?
Solve for T. So you would do 2 times 9.8.
Not yet. We need to find the formula. You see, the objective now of the third step is to solve the formula. Can we find the formula for R before we use the numbers?
Would you combine 2 and 4?
Yes, 2 and 4, yes. You can either use substitution. You can solve these two equations, yes. Can you write on the board, or
Yeah.
do you have pen? Yeah, so I can see how do you solve this problem. Yes, combine 4 and 2 and 4, yes.
And then would I substitute in the numbers?
Not yet, not yet. This equation would allow us to solve the formula first. Can you see? Can we find the formula for R? Because R is unknown, right?
Mm-hmm. So
Yes. So that is what we call the formula for the R, for the unknown. Can you see? By the time you found the formula, then you can use number. Please use number as not. I noticed many chemistry teacher use a lot of number and unit, okay, during the calculation.
Yeah.
You don't have to, because if once you know the formula is rather simple. You don't have to repeatedly copy these numbers, right? So you can use a number. You can insert. You can substitute the number you have. G is also G is known. G is 9.8. Yeah, 9.8 meters. S -2. That's right. That's a different mass. Yes, it must be very small, right? The radius must be very small in this hypothetical question.
I'm using a calculator.
Yeah, you use calculator. Yeah, I did not use the calculator.
The radius is 0.016.
Very small, very unrealistic, right? Very unrealistic. So because with this is subjective, right? We probably would not. We probably the velocity can be faster than that. So that was therefore. But that matter. The number is not is trivial. But important thing is that to solve this type of question, first I suggest you to list the given condition. If the unit is not the same as in the international system, you have to convert that. For example, if you got a centimeter, so you have to convert that centimeter into meters. That will guarantee at the last moment, the unit you obtained will be the unit in the international unit system. For example, what is R? What is unit for R? Meter, yes, that's right. So that's why. So step one is to unify this this unknown. So what do you think? Do you think this question is challenging?
I think that I probably would have struggled, but I think that creating the three different equations is really helpful.
That's right. You see, you have to separate that what is a physics problem and what is a mathematical calculation. Okay. So. Maybe you can pick up the example from your textbook. Do you have the textbook? Do you have,
yeah.
I will save that.
I haven't had a lot of a look at it because we only just started.
You just starting the circular motion. Okay.
Sorry.
Have you studied the Coulomb's law? Not yet. Electricity. Have you studied electricity?
Yeah, I think we did a bit of it last year.
Oh yes, if that case, we can discuss the hydrogen atom, because as an approximation, we can also consider the electron in the hydrogen atom is also doing the circular motion.
Mm-hmm.
You agree?
Yeah.
So if this is hydrogen atom, and at the center will be the proton, right? Center will be the proton, positively charged proton. And the electron will be, can we use these green colors? Electron will be in the orbit. Have you studied Bohr's model?
Yeah.
Yep. So that is a innermost orbit of hydrogen atom. Of course, eventually people know that this model, this circular motion model is not accurate. Have you studied the clouds, electron clouds? Yeah, because that's more realistic, because electron must be treated as a wave. But as the first approximation for the beginners, so we still can use this idea of this orbital motion, circular motion. So this is electron. So this is mass. This is the mass of electron. So electron. And this inside is a proton. So if you have studied the Coulomb's law, you know there's attractive force, the force of attraction. So they will attract each other. So the force is a centripetal force. So this force, if just remind you, this force, the force is equal to the K, a constant, multiply the charge. So that is the charge of this electron charge, and divided by the R squared. So R is the radius of this circle. So in this case, electron can be considered doing a uniform circular motion. So that is direction of the velocity. Okay, so in this case, just give you the hint. In this case, the centripetal force, in this case, the centripetal force is equal to this Coulomb force. I use these two examples to explain that you can make objects doing circular motion by using different force to provide that centripetal acceleration. So this is called the Coulomb's law. Coulomb's law, or you can call it the Coulomb force. So this is we're dealing with the hydrogen atom. This is hydrogen atom. Now, can we work out? Can we find this? How can we find the formula? Can we find it? Can we try to find the formula for the velocity? For the velocity of the electron. Of the electron in a hydrogen atom. Very small, right? Very small.
Yeah.
Okay. I can write this constant on this side, which is not important, but we need to find the formula first. Okay. See, in the Coulomb's law, the K is equal to 9 very close to 9. They use the number 8, that meant 8.99 multiply 10 to the power of 9. And the charge of electron is 1.6 multiply 10 to the power negative 19 coulombs. And the R, which is the radius of the hydrogen atom, is very close to 10 to the power negative 10 meters. Anything else do we need to know? And that's it. or the mass of electron. So mass of electron is very close to the, let me see, very small. It's 9.11 multiplied 10 to power negative 31 kilogram. Okay, these are the numbers we can use. But before that, can we work out the formula first? Do you want to try? So this is another example that electron is doing a circular motion, uniform circular motion.
You would have to create the two formulas.
Yeah, we need to find the relation between the velocity and these numbers and these quantities.
Yes.
Can we write these two formula here so that for the uniform circular motion, we can always use this formula. So one is centripetal force is equal to mass multiplied the centripetal acceleration. And the centripetal acceleration can be written as v squared divided by r. So these are the basic equation you can repeatedly use to solve your problem, to solve the particular questions.
Yes. So would you make AC equals v squared over r?
You can write, yeah, you can write here. This you can write the solution in this area. Yeah, that is the formula for the centripetal acceleration, equation 1, yes. Yes, the second equation. Do we need other equation before we go further? Yes, we need this formula for the centripetal force. Is R, yeah, that is R squared.
That's the, oh yeah, sorry.
Yeah, it's okay. Do you have pen? If you have pen, you can write. Do you use a pen or use a mouse? You got pen, good.
Yeah.
Good. Yeah, some students use a mouse. It's very hard to write. Okay, can we just help you? Can we, before you go, can we just rewrite this a little bit? We just make sure we got the proper. Can we just copy that for you? And we just rewrite this three formula you're going to use. So one is acceleration, or equal to the velocity squared divided by r, right? And the second equation is the centripetal force, or equal to m multiply ac, is our equation 2. Third equation, in our case, the centripetal force can be written as the Coulomb's law, at E squared divided by R squared, right? Okay, yep. What can you do with these three equations?
You could put 1 into 2.
You can try, yeah, you can.
Do I?
You can specify what you're going to do. You can do substitution. Do you want to substitute something?
Yeah.
Can we just do substitution? Can we substitute equation 1 and equation 3 into equation 2?
Mm-hmm.
Can we? So because we know the formula for AC, we also know the formula for FC. So if you put these two equations into second equation, then we should be able to see more closer expression we want. Yeah, that is a centripetal force on the left-hand side. It's good. It's good. Okay, this is our equation 4. Can we? Let's call equation 4. Can we simplify this equation 4? Can we find the formula for? You can solve it. You can just use algebra skill to solve this equation.
Would you times both sides by R?
Yes, you can, or you can just cross that. You can just cross this. Can you see? Let's cross this one. You agree?
Yeah.
Yep. So that will simplify this question. Now, can we solve this velocity? Because that is what we are looking for. We're looking for the formula for the velocity of electron.
Would you need to times both sides by M?
You can preferably you divide M. That's better, because if ultimately we are looking for the formula that everything everything is on the right-hand side. So the formula for velocity must finally have this form.
Yeah.
Yeah.
So you divide by M.
You divide by M. You see?
Yeah.
You can write it down. So what would happen? What can we obtain?
Would the M go with the times the E on top?
Yeah. So you what you're going to do? You're dividing it, right? You're dividing divide on both sides. Yeah. On the both sides. Yeah, sometimes you write this short description to remind you what you're going to do. It's also a good habit to let the teacher or to let the reader know what are you doing, right?
Yeah.
If you divide M, what will be outcome?
V squared.
So V squared. Can we swap this left and right hand side?
Yeah. Equal to
M become denominator, right? Is that? Can we write it this way?
Isn't it if you divide a fraction by a fraction?
Yes.
It goes to the top.
Oh. Just one moment. Yeah. So you this might divide. What can you do? Can we follow you? Do you want to try?
No. I think you're right. I'm
right.
really bad at algebra.
Oh, I see. Doesn't matter. This is a good opportunity for you to improve your skill, right? I'm just watching. Doesn't matter. You can try. You see the best way to learn any subject, physics, is doing the trial and error. You see, do you know the trial and error method? You try it. If you make a mistake, you don't repeat, you learn. Do you understand? Yeah. You can. K is constant. Yeah.
Would the M be on the top of the fraction or the bottom?
Yeah, so you are not sure, right? Can we just copy this? So you got this equation. Can we copy this equation 4? So that we got a fraction on the right-hand side. On the other hand, we got a product of M multiply V squared. Now, if we divide by M on both sides, what would happen? If you divide is M on both sides,
I don't, does, isn't, well, that would,
Can we just say, can we just multiply? Probably if this is a dividing, it bother you, can we just multiply it? Can we just rewrite that as this fraction? If we just multiply something, can we? Is that okay? We
yeah,
just multiply, it's the same thing, but we multiply the 1 over m is equal to divide. You agree?
yeah,
That probably will help you, right?
yeah.
So in this way, so because this is a product of two fractions, because the product, then that will just equal to numerator multiply numerator, and the denominator multiply denominator. Do you agree?
Yeah.
And in this case, you can just put this m over here, which will be cancelled. You see?
Yeah. Yeah, that makes sense.
That is v squared formula now. Can you
So
see?
it's square root, you would square root the,
Yeah.
so v would be equal to,
Yeah. You just swap this formula. Can you see? We just swap this formula. Yeah, finally, you can use the square root to get rid of the square terms. That's right. That's right. That is formula. Can you see? If you want to simplify this a little bit, we can put this e square and square root will cancel. We can put the e in front. Can you see that?
yeah,
Because we have, because it's e square root is just equal to e, right?
mm-hmm.
That's it. So that is a formula. So that is a formula for the velocity, right?
Mm-hmm.
And then you can substitute these numbers if you have time. Okay, I think that is the easy part, right? By just using the number, that is the easy part for you, right? Because you are a little bit concerned about this algebra, can we do more exercise?
Mm-hmm.
Okay, so we have solved this problem. Do you agree?
Mm-hmm.
We have found the formula for the velocity of electron. Okay.
Mm-hmm.
So after this, you can substitute this number to see how fast electron move. What do you think? Do you think it is faster than speed of light or not?
No,
No. Why not?
because it's
It's
the
assumption,
numbers
right?
on the top are small.
Ah, you guess so? We probably will do some numerical exercise as well. Can we just clean up something? And if we just 1 moment, it's interesting to know the number of velocity. Let me just say, oops.
Yeah, I have a calculator.
Yeah, calculator. Yeah, can you just substitute the number into calculator to see the number?
Yeah.
I think it should be very fast, but not necessarily faster than light speed. Oh, 31.
Yeah. It's fine. Yeah. It's 3.975 times 10 to the 15.
Oh, can you write it down here? It's very fast.
Yes.
Can you write the number here?
Yeah.
.9. Yeah. 10. 15. Wow, that is faster than speed of light.
Oh, is it?
Yeah, something wrong with our number. I think I will double check my number. All right. So the Coulomb constant is 8.99 multiplied 10 to the power 9. That's right. The mass of electron is 9.9, 10 to the power negative 31. That's right. And the radius is negative 10, 10 to the power negative 10. How come you got this huge number? Double check our formula. Ke square R. Yes, we are, and divided by m. Can you double check your result?
Yes.
It could be, it's very fast, but should not that fast.
So I had 8.99 times 10 to the power of 9.
Oh, still faster. Faster.
Like no, for K, I had that for K.
Yeah.
And then I had that over 10 to the power of negative 10 times 9.1 to the power of
that
10.
is that's a denominator, right? Square.
Yeah.
Did you use a square root as well?
Yeah, and square root, and then timed by the coulombs.
That times 1.6. Yeah.
Yeah.
1.6.
So it's 10 to the negative 19.
Yes. That is what is number now? 8 something.
Wait.
It's different now, the number.
Okay, yeah, I didn't put the square inside the square root.
Square root, yeah.
So it's wait.
Yeah, if you put a square root, that'd be reasonable because.
No, I forgot. I put the e inside the square root, but I forgot to put e squared.
Yes. Oh, if you put the e inside, it should be e squared. Yes.
Yeah. Sorry, my
it's okay.
Stop working.
Yeah, it doesn't matter. You see, it should be less than speed of light. Probably say 10 to the power 7 or something.
2. Does that look right?
1, 2, 3, 4, 5, 6. Yes. 1, 2, 3, 4. 1 million, right? 1, 2, 3, 4, 5, 6. Yes, let's Google that result. Okay, it's we should be able to find. Can we just stop here? We can Google that result for you. Let me see. So electron speed, hydrogen atom. Look that result. 8.8. That's right. Oh, they got different unit. 6. Yeah, very close. Very close. Can you see this one?
Yeah.
Is that similar to that?
Yeah.
That's good.
Yeah.
So today we have to actually calculate that velocity. Is that amazing? You see, we just apply Newton's law and Coulomb's law. We can actually, one moment. We can actually work out that velocity, right?
Yeah.
And
Yeah.
similarly, we can go to another, quickly go to another example. This time, let's go to the, let's calculate the velocity of Earth about the sun. At least we can find the formula first, right? So that is, so the sun is at the center. Can we use m to denote the mass of the sun?
Yep.
And we use a small m to denote the mass of the Earth. Again, this time, the force is invisible, okay? This time, the force is provided by the, we just discussed that, the so-called gravitational force, okay? So gravitational force, we're acting as a centripetal force in this case. So this is, so basically we have the force, the gravitational force. Can we just write the formula here? So giving the gravitational force F is equal to G is constant, multiply the two mass, the product of two mass, divided by the R squared. So R is the distance from the sun and the earth. So this is R. So this is, you can consider the first formula. Other formula are the same. So centripetal force is equal to mass of Earth multiplied the velocity squared divided by R, equation 2. And the centripetal acceleration, oh, we have combined this formula already, okay? So in this case, the centripetal force is equal to the gravitational force. So this force is gravitational force. Gravitational force. Okay, got a 3 equation. Now, can we also find the formula? Can we find the formula for the velocity of Earth? The velocity of the Earth. Formula, can you find the formula just?
If the centripetal force is equal to the gravity force,
yes,
you can combine the two.
Yes, you can try. You can write down here. Yes, you can say, you can either say substituting or you combining two equations.
Yeah, substitute.
Substitution. Yeah. Or you can use SUB for short. Do you want to substitute equation 1 and 3, right?
Yeah.
And 3 into 2. Yeah, you can do, follow this instruction.
That's
right. G is a constant, so this is a gravitational constant. It's called the gravitational constant. G is a very small number. Yes, this is our equation 4. Can we solve the formula? Can we find the formula for the velocity of the Earth, which is in the tangential direction?
So would you, if you divide both sides by m?
Yes.
Just
the mass of Earth will disappear. Do you agree? If you divide this divide the mass of
Yep.
Earth. And so what you can do, in that way, you just communicate with people just cross this M at the same time. Can you see?
Yep.
What else can we simplify this equation?
The R's.
Yes, you got R here, 1. You got 2 here, right?
So V squared would be equal to M over R.
Yes. What
So velocity.
can you write down the result after this simplification? Yes. You missed the constant, gravitational constant, capital G.
Yeah.
Where's the capital G? Yep, GM. Yeah, that's right. Okay. This is similar for the formula we discovered for electron, right?
Yeah.
Except that constant are different. Square root divided by R. So R is the distance between the sun and Earth. Yes, that's it. That is the formula for the velocity of Earth orbit about the sun. So today we have studied the huge circle and very tiny circle. And probably the first one, if you want to make this problem more realistic, probably will have increased its velocity, all right?
Yeah.
So make this scenario more realistic. But from here, you can see that when you see the objects doing the circular motion, one thing is certain: there must be the force attached, force the object to turn toward the center. That force is a centripetal force. Okay. But the centripetal force can be acted by different source. In the first example, we just use a wire, a rope, rigid rope, right?
Yep.
But in the last 2 examples, the force is invisible, but it's we know it's attraction, right?
Yeah.
That is how circular motion can be observed, either in the solar system or inside atom. I hope we can continue to talk about more example. All right. Another example, you have to think. Do you like to run? If you run very fast, when you trying to turn, you have deliberately push yourself inward. Otherwise, you cannot turn. Do you agree?
Yeah. Yeah.
Well, this is similar to the car racing. See, the bike in the Olympic game, they got a cyclist. So they have built this special track, so that we can provide this inward or centripetal force. Otherwise, you cannot ride too fast.
Yeah.
Okay.
Yeah. Thank you very much.
Okay, we'll continue.
I'll see you next week.
Next week. Okay. I will see you.
Thank you.
You're welcome. Goodbye.
Bye.
Goodbye.